Hello and welcome back. This is Saxon Math, Lesson 42, renaming fractions by multiplying by 1. In this lesson, with our fraction manipulatives, we have seen that the same fraction can be named many different ways. Here we show 6 ways to name the fraction 1/2. 1/2 is equal to 2/4 is equal to 3/6 is the same as 4/8 is the same as 5/10 is the same as 6/12. We could go on to infinity. There would be 7/14 and 8/16 and 9/18, and it goes on forever in this pattern where you see that 7 is half of 14, 8 is half of 16, 9 is half of 18, 6 is half of 12, 5 is half of 10, 4 is half of 8. These are all ways to name half or 1/2. In this lesson, we'll practice renaming fractions by multiplying them by a fraction that is equal to 1. Here we show 6 ways to name 1 as a fraction. 1/1, 2/2, 3/3, 4/4, 5/5, 6/6, on to infinity. Those all equal 1. We know that when we multiply a number by 1, the product equals the number multiplied. So if we multiply half by 1, the answer is still going to be half. That is the identity property of multiplication. It states that if one of the two factors is 1, the product equals the other factor. So if you have half and it's times 1, it's going to equal the other factor, which was half. See, it stayed the same. However, if we multiply half by fractions that are equal to 1, we find different names for half, which is still going to be equivalent to half. So here we show half multiplied by 2/2, which is the same as 1, 3/3, which is the same as 1, 4/4, which is the same as 1. So 1/2 times 2/2 equals 2/4, which means this is still the same. These are equal. 1/2 times 1 is 1/2, but this is just renaming that 1/2 if we multiply it by 2/2. See? Or 1/2 times 3/3 equals 3/6. So this is just another way of naming 1/2. Or 1/2 times 4/4 equals 4/8. So you can see that 4/8 is just another way of naming 1/2. They're equal to each other. So, and why is that? Because the identity property of multiplication states that if one of the two factors is 1, the product equals the other factor. 2/2 is 1. 3/3 is 1. 4/4 is 1. Now if we did 1/2 times 6/6, this is also equal to 1. And 6/6, that'd be 6/12. So you see 1/2 is the same as 6/12. Fractions with the same value but different names are called equivalent fractions. The fraction 2/4, 3/6, and 4/8 are all equivalent to 1/2. 1/2 would be considered the reduced fraction of those. So we'll write a fraction that's equal to 1/2 that has a denominator of 20. So in this case, you would have to multiply 1/2 times 1. But what is that fraction going to be equivalent to that has a denominator of 20 and an unknown numerator at this point? So if you know that 2 times something equals 20, you know that 20 divided by 2 is going to equal this. So 20 divided by 2 is 10. That means this also has to be a 10 here. This would have to be a 10/10 in order for it to be equivalent to 1. And then this 1 times 10 equals 10. So 10/20 is the fraction that is equal to 1/2. 10/20 is 1/2. So to rename a fraction, we multiply the fraction by a fraction that is equal to 1, which is in this case 10/10. The denominator of 1/2 is 2, and we want to make an equivalent fraction with a denominator of 20. So because of that, you have to recognize you would have to multiply this denominator by 10 to get to 20. So that means it was 10/10 was the fraction that's equivalent to 1 that we would multiply it by. Then we can find the numerator from there. Let's try another one. Example 2, write 1/2 and 1/3 as fractions with denominators of 6, then add the renamed fractions. So if I have 1/2 and I need a denominator with 6, and I also have 1/3 and I need an equivalent fraction with a denominator of 6 as well, this is what I'm looking at. I notice that 6 divided by 3 equals 2, so 1 times 3 equals 3. 6 divided by 2 equals 3, so this would have been times 2 up here, which gets me that. And then if I'm going to add those, I have 3/6 plus 2/6 equals 5/6. That would have been the finished answer to that addition problem. So we multiply each fraction by a fraction that's equal to 1 to form fractions that have denominators of 6. So when you notice that, we multiply 1/2 by 3/3. So to multiply this by 3/3, you end up with that 3/6. So this would be 3 here. And this 1/3 would be multiplied by 2/2, which would end up being 2/6. Then the renamed fractions being 3/6 and 2/6, you just add the numerators and the denominators stay the same. 5/6 would be the answer. All right, let's try some practice problems here. In problems A through D, multiply by a fraction equal to 1 to complete each equivalent fraction. So for letter A, you have 1/3, and it has to be multiplied by something to equal a denominator with 12, a fraction with a denominator of 12. So what do you have to multiply 1/3 times? In this case, let me give you this much. 12 divided by 3 is 4, so that means I have to have 4/4. Go ahead and answer letter A. You should have gotten 4/12 would have been the equivalent fraction to 1/3. So 4/12. Letter B. So let me set it up again for you. 2/3 times some fraction that equals 1 equals a fraction that has a denominator of 6 with an unknown numerator. Go ahead and answer letter B. So I recognize here that 3 times 2 equals 6. So that means I have to take the numerators, 2 times 2 to equal 4. 4/6 would have been the answer for letter B. Letter C, 3/4 times an unknown fraction that it's equivalent to 1 equals a fraction that has a denominator of 8. Go. 8 divided by 4 is 2. 3 times 2 is 6. So this would have been 6/8. And letter D, 3/4 multiplied by a fraction that's equivalent to 1, which will get you to 12, or a fraction with a denominator of 12. Go. So 12 divided by 4 is 3. And since I need it to be equivalent to 1, I need a 3 up here. So 3 times 3 would be 9. This would be 9/12. All right, let's try some more practice problems. Letter E, on your paper, draw 2 rectangles that look like this one. Well, I've got it drawn out here for you. So we have to shade 2/3 of the squares in one rectangle and 1/4 of the squares in the other rectangle. So 2/3 would be like this. You can see that this is 1/3, this row would be 1/3, this row would be another 1/3, and this row is 1/3. So that means shading all of these squares here makes up 2/3. So recognize that this represents 2/3, all that shading. And 1/4, you can see this is split up into 4 equal parts here. And if we shade these 3 boxes of the 12, you end up with 1/4 here. So it says name each shaded rectangle as a fraction with a denominator of 12. So you might be able to look at it and just count. So what would you get for E in both the 2/3 equivalent and the 1/4? So name the fractions that have a denominator of 12. So what would be the fraction? Not just the numerator. Give me both the numerator and the numerator and the denominator answer for 1/4 with the equivalent fraction with a denominator of 12. All right, for this one, you should have gotten 8/12, this part, and then you would just answer this one. You see that it would be 3/12 for this part. So these two parts right here would have been the answer. This is considered 2/3. This is 1/4. All right, letter F, write 2/3 and 1/4 as fractions with denominators of 12, then add the renamed fractions. So we're looking for what the sum of the addition problem when adding those fractions. So it's already done for you there. You've got 8/12 plus 3/12. So what would you end up with? 11/12. That would be the answer. And letter G, describe how the rectangles you drew for exercise E can help you add the fractions in F. So if you recognize this, that both of those rectangles represent the fraction, the numerator, with the denominator of 12, you can see that all you would just have to do is add those fraction pieces together. So you can add up 2/3 and 1/4 equivalents. And letter H, write 1/6 as a fraction with 12 as the denominator, and then subtract the renamed fraction from 5/12. So 1/6, we need to have an equivalent fraction with 12, and then it says subtract the renamed fraction from 5/12. So whatever the answer to that is, we're going to take that away from 5/12. So 1/6 as so just go ahead and give me this final answer over here. When you take 5/12 minus whatever this fraction is going to be, which is going to be something over 12, and then your answer will be with that. It may need to be reduced. Go. All right, in this case, you can see that 12 divided by 6 is 2. So that means 1 times 2 is 12. So this is 2/12, or sorry, 2. And then 5 minus 2 is 3/12. I guess I'll accept 3/12, but reduced fraction of that would be, if you recognize this up here, it would be 1/4. The most ideal answer would be 1/4. It's reduced. It is an equivalent fraction, and we're talking about renaming fractions anyway. So I'll accept both of those, 3/12 or 1/4. All right, that's it for today. Nice job following along. If you missed anything, don't forget to go back and watch it over again until you understand it. If you have any questions, raise your hand. All right, we'll see you next time.